All right, guys, we're going to start out talking about points, lines, and planes. Okay, here we have some definitions, and we're going to write in the terms, and then we're going to talk about how to name it and what it actually looks like. Okay, so a point indicates a location and has no size. Okay, so this is a point. So a point indicates a location and has no size. Okay, we name it by a dot, and we give it a letter, mostly a capital letter, and a letter. Okay, so here's our dot. I'm gonna call it A. So A will be capital. Okay. Now moving on. A blank is represented by a straight path that extends in two opposite directions without end, that has no thickness and contains infinitely many points. All right. Now this is a line. Okay, a line. Everybody knows what a line is. Now we name a line by any 2 points or by a single lower case letter. Okay, so here I have a line. I'm going to put a dot here and here. We'll call it A, call this B, and then I'm going to call it line L. Okay, so we can name it either AB. Okay, pay attention to the notation. BA or line L. Okay, now a blank is represented by a flat surface that extends without end, has no thickness, and contains infinitely many lines. Okay. Now this is a plane. A plane. Now we name a plane by a capital letter or by at least 3 points that are in the plane, okay, that are in the plane, but they don't lie in the same plane, all right, and or they don't lie on the same line, and this is what I'm talking about. So here we have our plane. We'll call this point A, point B, point C, all right, and now we could call it plane P, or we can call it plane A, B, C. Okay, and notice A, B, and C are not on the same plane. Okay, all right. Moving on. Points that lie on the same plane are collinear. Okay, they are collinear. And points that lie, or points and plane, or points and lines that lie in the same plane are coplanar. Okay, coplanar. And all of the points of a line are coplanar. All right. All right. So over here we have a plane with some points and lines. And part A asks us what 2 other ways to name line QT. Okay. So we want to look at this line right here. Now we can name it not only QT but TQ. And if you look back, it also says we can name it by a single lowercase letter. Well, here we have line M. Okay, M is that lowercase letter, and it represents that one line. Okay. Now, what are 2 other ways to name plane P? Well, if you look back, we can name a plane by at least 3 points that do not lie on the same line. So I could do plane RQV and plane QSV. All right? RQV and QSV. Now, what are three collinear points? Okay, what 3 points lie on the same line? Well, if you look at line L, we have R, Q, and S. All right, and what are the names of the four coplanar points? Well, we have R, Q, S, and V. Now, we wouldn't name T or N because they are not in the plane. They are on a line, but not within the plane. All right, so here we have a segment. It's part of a line that consists of two endpoints and all points between them. So we name a segment by its two end points. So here I have point, then my line, and then a point. So let's say this is point A, and this is point B. Now I can name this line segment AB or BA. Okay? Now, a ray is a part of a line that consists of one endpoint and all the points on the line on one side of the endpoint. And we can name a ray by its endpoint and another point on the ray. So for example, here we have a line. Here's my endpoint. Here's another point. Here's my arrow. We'll call it AB. Now I can name it AB. Now I can't name it BA because B is not the endpoint. We always start with the endpoint. So the endpoint is AB. All right. All right. So blank are two rays that share the same endpoint and form a line. Okay. These are opposite rays. Okay, and we name them by the shared endpoint and any other point on the ray. Okay, so here I have a line. Let's say this is our endpoint. We'll call it C. Point here, this is A, this is B. So we could say CA and CB are our endpoints. All right, so we're going to do a little exercise here. We are going to name the segments that are in the figure to the right. Now remember, the figure is named by two endpoints. All right, so here we have DE, EF, and DF. Now, we can write these vice versa, so we could also name them ED, FE, and FD. Okay, so either or, it doesn't matter. Okay, line segments do not matter. All right, so here we have part B, and it says, what are the names of the rays in this figure, okay? On some of these, we will have the same ray, but we can name it different ways. So we have DE or DF, because D is the endpoint, and then E and F are another point that lie on that line, okay? And then we have ED, EF, FD, or FE. All right, now part C asks for which of the rays in part B are opposite rays. Okay, so a common endpoint and then another point that lies within that line. Okay, so we have ED, and EF. Okay, those are our opposite rays. Now, when you have two or more geometric figures, their intersections is the set of points the figure have in common. In Algebra 1, you use intersection points to help solve systems of equations. All right, so in this exercise, we're going to do a little bit of thinking, basically. It says, how many lines can we draw through two distinct points? So let's say we have 2 points. Right here, we'll call them A and B. Well, how many lines can we draw through those 2 points? Just one, right? Just one. So only one line can go through 2 points. All right. Now, how many times do 2 distinct lines intersect? Well, let's look. Okay. Well, here I have a line, and here I have a line. All right. And now they only intersect right here at this specific point. So we could say one time at a specific point. Okay. Now, what geometric figure is created when 2 planes intersect? Okay, this is going to be a little bit difficult, but I'll try my best to draw. So here I have one plane, and then I'm going to pick another color. And then here is my second plane. All right. Now, right here is what we're talking about. All right, this is where the 2 planes intersect. So, what geometric figure is created when 2 planes intersect? Well, it is in fact a line. Okay, a line is created when 2 planes intersect. All right, part 3, it asks us, or it tells us, in each surface of the box at the right represents part of a plane. What is the intersection of plane ADC and plane BFG? Okay, well, first thing I'm going to do is I'm going to identify what plane ADC is. Okay, and it is this plane that is on top of the cube, and then plane BFG, which is to the right if we're looking at it. Okay. And the line, or the intersection of those 2 planes, are this line right here, okay? And we call that line B, rookie mistake, line BC, okay? All right, in part A, it asks us what plane contains points in PQ, okay? So what I want to do is I want to try to identify the plane that has points in P and Q in it. All right. Well, if you look here, it is the bottom of this rectangle box. Okay. So I'm just going to shade it in right here. Okay. Now it says what plane contains points J, M, and Q? Shade the plane. Well, if you look, this is JM, and this is Q. Well, we kind of have like an imaginary dotted line right here that goes from J to P and M to Q. Well, if we shade that little piece right here, well, that is in fact our plane that contains J, M, and Q. All right.